two things we're going to be doing now is looking at, okay, if I know the equation for my parabola, can I figure out where the focus and the directrix are? Okay. And the other thing we're going to need to do is, okay, if I have a graph of a parabola and the focus and the directrix are already known, okay, can I come up with the equation for the parabola? Okay. So in order to do that, we're going to look at the equation in a slightly different way. So you can see this particular parabola, I have the equation for it set up as x squared equals 4py. Okay? In the past, when we had parabolas that had a vertex at the origin, we used y equals ax squared. Okay? And then that value of a told us the vertical stretch or the vertical shrink for the graph. Okay? So now we've moved that sort of constant over to the other side of the equation, so it's not really set up like a function anymore. We haven't solved for y, and now we're looking at sort of a slightly different setup. Okay. Now, the other thing to note here is that I have this value of p, okay, set up at p equals 2. Okay. So if I wanted to actually write out the equation for this, it would be x squared equals 8y. Okay. P equals 2. 4 times 2 is 8. The important thing about that value p, okay, is that once you know what that value is for that letter p, and I don't know why math textbook shows the letter p, but that's just what we use. Okay, but once we know that value, if the vertex is at 0, 0, then we can very easily find the directrix and the focus. Okay, the focus is always just going to be at the point 0, p. Okay, so as soon as you know what the value of p is, okay, you know where the focus is. Okay, because the equation we've graphed is has a value p equals 2. Okay, the focus for this parabola is at 2. Okay. Similarly, the directrix, okay, its equation will be y equals the opposite of p. Okay, so p in this case is 2, so our directrix is at y equals -2. And that's how the equations for these parabolas are going to work. Now, I'm going to, in a minute, we'll go over to the iPad, and I'll do a little bit of math looking at, okay, here's an equation for a parabola. How do we figure out where the focus and the directrix are? And then and do some practice there. But I also just want to show you, that the way this graph is set up, I can change that value of p, okay, and as that value changes, okay, notice that both the graph, okay, is changing. I've made p larger, which means the parabola itself has gotten wider. It's opened up, okay, which means it's vertically shrunk, and the focus and the directrix have started to move away. Okay. Because now p is 5.3, so the focus is at 0, 5.3. The directrix is at y equals -5.3. And then if I make p negative, I think it still works. I couldn't remember if I'd set this up properly for this. If I make p negative, the graph flips. Okay. P is now -3.7, which means now our focus is at 0, -3.7, and our directrix is at y equals positive, because it's always the opposite, positive 3.7. Okay. So that's visually what this all is going to look like. All right. I now have a graph of a parabola. I should set this back to 1. Okay. And every parabola has an imaginary point associated with it called the focus, and an imaginary line associated with it called the directrix. Okay, and we can and they have these properties associated with them. So let's talk about now if I've got an equation for a parabola, how do I find where the focus and the directrix are? Okay. So I'm going to switch over to my iPad. We'll do a little math. All right. So we're looking at parabolas, and specifically we're learning about our focus and directrix. So when we're talking about parabolas in this context, when they open up or down, and we'll get to parabolas that open left or right a little bit later, but when they open up or down, we most often want the equation for the parabola to look like this: x squared equals 4py. So I'm going to do one, maybe two examples where it looks like this. We figure out what that value of p is, and then identify where the focus and the directrix are. And then we'll do one example where it's not set up in this form, and then, okay, how do we get it into this form so that we can figure out the focus and the directrix. Okay. So, all right. Once again, this is the form we're using. Now, if I have a parabola with this equation, x squared equals, say, 12y. I want to know where its focus and directrix are. So the way I'm going to do that is, if I look at both the formula here, x squared equals 4py, and then the equation that I have, they both have an x squared, they both have a y. The difference is one has 4p and one has 12. So what I'm going to do here is, because they're both in the same place, I can set 4p equal to 12. Because that's what I want to figure out. I want to figure out, for this parabola, what would the value of p be? And so we solve for p, divide both sides by 4, and I get p equals 3. So once you identify what that value is, what is p, now I know exactly where the focus is. The focus is at the coordinate 0, p, so it's at the coordinate 0, 3, because that's what p equals. And the directrix is at the equation y equals negative whatever that value p is, or the opposite of p, so in this case it's negative 3. Okay? And that's all you have to do. All right, you're going to look at the equation. You're going to identify, first of all, is it set up the way we want it to? And then identify, okay, what does 4p equal? For this equation, 4p equal 12. We set 4p equal to 12, solve for p, and then get our focus and our directrix. Okay. So let's do one more. So once again, we're looking at x squared equals 4py. This time I'm going to say x squared equals, let's say, negative 6y. All right, so once again, I want to know, in order to find the focus and the directrix, I need to know that value of p. So I'm going to set 4p equal to negative 6, because that's the number that y is being multiplied by. Solve for p, divide by 4. So p equals, and I'll go ahead and simplify, negative 3/2, or negative 1.5. So for the focus for this parabola, I have a focus at 0, negative 1.5, or negative 3/2. and I have a directrix. And remember, the directrix is always the opposite of P. So in this case, because P is negative, our directrix is at y equals positive 3/2. So the sign for the focus and the directrix will always be opposites of each other. Okay? If one's negative, the other one's going to be positive. So that's how we would find where's the focus and where are the directrix. So just to show you back on Desmos, okay, we did two examples. We did one where it was x squared equals 12y. And so if I make p equal to 3, we can see that 3 times 4 is 12. And we can see on the graph that the focus is at 0, 3, and the directrix is at y equals -3. And then if I make this p equal to -1.5, all right, now the parabola is opening down, and -1.5 times 4 is -6, so that was our equation, x squared equals -6y. And our focus is at 0, -1.5. Our directrix is at y equals positive 1.5. Okay, so that's the first thing that we have to know how to do is, here's an equation for a parabola. How do we find the focus and the directrix?